Broadcast is now starting. All attendees are in listen-only mode.
Good evening, everybody. This is Mark Miller, your Executive Director of the Passive House Alliance, United States. Welcome to this evening's webinar with our guest presenter, co-founder and Executive Director of the Passive House Institute US, Katrin Klingenberg, who's going to be introducing the new WUFI Passive tool to everybody tonight. It's an exciting evening. We have a record-setting online attendance crowd joining us today, so sit back and enjoy. I'm going to take a few minutes here in the beginning, since we have such a large audience, to introduce folks to the Passive House Alliance and all the good work that our members are doing around the country to help fulfill our mission of bringing passive building into the mainstream U.S. building market. A lot of folks ask us, what's the relationship between the Institute and the Alliance? And the best explanation that I've seemed to come up with is to describe PHIUS as the university or graduate school. Their role is to uphold the integrity of the standard and do cutting-edge research on the building science involved in promoting and expanding in the Passive House standard, as well as trainings and certifications. The Alumni Association is a way to describe the Passive House Alliance, where we are keeping all of the members who have come out of the PHIUS trainings together, establishing chapters all around the United States where folks are locally giving presentations on the benefits of passive building and getting folks involved in their communities, and more importantly, getting the consumer aware that these benefits are available to them, and all the good reasons that you want to bring passive building into your next project. We like to look at the Alliance as kind of the center of a hub, trying to bring in all the various sectors of the building industry together to open up lines of communication so that we can bring passive building to a higher level of implementation. One of the great benefits of being involved in the Alliance and with PHIUS is the premier passive building conference in North America. Last year we were in Denver. We had Joe Stebrick and Amory Levins as our keynote speakers. We had a field of about 60 exhibitors exhibiting building products to the high performance and passive building professional. There was a nice dinner that evening, and 2 days chock full of 4 rooms with presentations from these pioneering architects and builders who are building passive buildings today and sharing the lessons learned in the field at the conference. And stay tuned. I think soon we'll be announcing the city location for this year's conference. If you're not familiar with where your chapters are located, this map illustrates the first 12 chapters that are established and are running now in these areas around the country. As far west as Portland, Oregon, and as far east as Vermont, from Minneapolis down to Austin, Texas. We also have some new chapters forming, which we're very excited about, in the Northern Rockies that will cover Montana, Idaho, and Wyoming. Long Island, New York, and the New Jersey area, Utah, and San Diego is already just past their second meeting this week. And if you're interested or near any of these groups, you can go to the PHIUS website and go to our chapters page, and there's links to get in touch with these folks so you can get involved locally. I also want to point out that the Alliance has a really wonderful website that is designed to communicate the benefits of passive building to the consumer and the curious building professional, as I say. Someone who's dipped their toe in the energy efficiency waters and they really want to climb up the ladder. And the website is a great place to find information. In the About PHIUS page, you'll find information on our mission, organization. The chapter locations are found here. Some information on our board of managers and the various committees that we have going on that are doing good work to promote passive building. And if you're looking to find a professional around the country who can assist you in your project, whether they're a certified passive house consultant or a new PHIUS certified builder or PHIUS Plus rater. This is the place to come to find those folks. Then in the Learn section, this is where you go to get all kinds of good information about what is Passive House. There's an extensive library with articles, videos, podcasts, books, and tools. There's a wonderful case studies area with a downloadable color 4-page magazine quality story about a handful of projects that have been completed over the past few years, and interviews with the architects, the builders, the passive house consultants, and more importantly, the building owners. You will also find information if you want to get involved in some of the PHIUS training classes. You can find information on the Certified Passive House Consultants training here, the Builders training, and the Raters training. The next section is a join and support section where you'll find information on becoming a member to the Alliance and all the benefits it affords to you, information on our sponsorship program and our partners program. And then there's also a growing members-only area, chock full of information. The webinar that you're going to see tonight will be recorded, and in a week will be hosted in this library. There's already a few dozen webinars from the past year up in this area. And this is a really wonderful benefit of the professional level of membership. You will also find here the National Events Calendar. You can see tonight's presentation listed, but this is a great place to check into every week to see what events are going on all around the country, webinars, conferences, and meetings of your local Passive House chapter. And we just started a new section in the calendar called Passive Building University. It's a quick filter that goes through all of the events and filters out into 3 main categories if you're looking to get involved in continuing education. So the first button will have all of the trainings that PHIUS is offering around the country. The next is the fundamentals, where we are leveraging our partnership with the Building Science Corporation, and they are offering various classes through our Passive Building University here. And then graduate level courses, which are like WUFI Passive, which you'll be learning about this evening, and other advanced building science courses. So another great benefit of being involved in the Alliance is our national webinar series, and tonight's presentation is a part of that. We have presentations lined up all throughout the rest of the year, and you can find out as these become available on that calendar and in our newsletter. So here is the one for this evening that we'll be getting to shortly. And a little information, if you are a member of the Alliance at the professional level, you will get discounts on the trainings that we just discussed, the consultants, the builders, and the raters trainings. In terms of upcoming trainings, we have in Chicago here a WUFI Passive training that Katrin's going to talk a little bit more on. Also, Portland's going to be offering one in June. And then it's become very popular. The PHIUS Certified Builders Training is already sold out in Golden, Colorado in April, but it's looking like another class is going to be forming in Seattle, perhaps in June, and that'll be announced shortly in an upcoming newsletter. Your professional level membership also provides you discounts to the PHIUS Plus certification program. So as you can see, just taking advantage of a few of these things is paid for your membership completely. The Alliance, big part of our mission is to do outreach. And the way we do that is our weekly newsletter. We're also involved in various events around the country. Just a few months ago here in Chicago, we had the Das Haus tour, which was a mini Passive House that was touring North America, and the Passive House Alliance Chicago chapter and Denver chapters hooked up with the German-American Chamber of Commerce, and we helped provide various poster boards, as you could see in the photos here, for that project with various Alliance member Passive House projects for the public to see. We also have a partnership program, and here's a sampling of some of the great organizations who are also very keen on energy efficiency around the country that we are doing work with. And then one of the greatest partnerships that occurred just recently is the Challenge Home and the connection with the Department of Energy that PHIUS has created. So now if you have a PHIUS Plus certified passive house project, it will automatically qualify for the Challenge Home certification as well as the Energy Star designation. So everyone's very excited about this new relationship. We have a wonderful sponsorship program. If you are a building product manufacturer trying to reach the passive house community, this is a way to get involved. There's information you could download from our website. And here's a sample of some of the companies that we're working with now on bringing them and connecting them to our members. I also want to thank some of our upper level sponsors, CertainTeed, Intest Windows, Tremco, Prosoco, Ultimate Air, Mitsubishi Electric, and Chemlink. So if you're new to the Alliance, we welcome you to join our movement. So thanks everyone for attending tonight, and if you bear with us a minute, I'm going to throw the microphone over to Katrin Klingenberg, our guest for this evening.
Hey, Mark.
I can hear you,
Can you
Kat,
hear me?
so I think they can hear you. Let me just...
We still need
Here
to
we
switch.
go. Yep, it's coming over to you now.
Okay.
All right. Well, everyone, I now present to you Katrin Klingenberg, the Executive Director and Co-Founder of the Passive House Institute US. Welcome, Katrin.
Thanks, Mark. Well, it's once again a really great honor and pleasure to be with you tonight. I have started to really like these presentations about WUFI Passive, as this really appears to be the new thing that is going to take off here fairly quickly. I'm really excited about this. So maybe quickly a word about how WUFI Passive came about. I was just out at the Passive House Northwest meeting in Seattle, and it was actually almost exactly 2 years ago that a few Passive House excited folks got together with Achilles Karagiozis from Fraunhofer and Owens Corning, and they said, what if? What would be the ideal world if we could ask somebody to build us the ideal modeling tool? And this is essentially the result. Like Fraunhofer and Owens Corning got really excited about the idea. They asked PHIUS to join the team to contribute the experience from the last almost 10 years now in terms of certified projects all around the country. And the result is a pretty impressive new modeling tool that, as we go through this, has the capability to help us as designers to really inform the design of our projects in more climate-specific ways. So let's get started on this. I like to structure this just essentially into two parts. First, the limitations of previous tools and why a new modeling tool might be needed. So kind of like this genesis moment in the Northwest 2 years ago. And then a brief introduction to WUFI Passive. All right, so if we start looking at the limitations of the previous tools and why we felt that there was another modeling tool needed. In general, the current modeling tool, the PHPP, is a static calculation, which is essentially a simplified method, a kind of flattened dynamic model that is very good in optimizing and speeding up the modeling process. It uses annual or monthly climate data, and this is the reason why the model can be run much faster, of course, compared to hourly data. The limit that we are incurring once we use such a simplified method is that we don't have really any ability to predict the thermal inertia or the thermal lag time of thermal mass very accurately. And as we're starting to design in North American climates and we get into either cooling dominated or humid climates or hot and humid climates, at that point, the dynamic model starts to make quite a bit of a difference. So this is the one limitation that we have here in the static model. The next limitation that we find is that for the PHPP, we have a very nice verification in terms of accuracy of the model for Central European climate. We do not have a validation for all North American climates yet. So that is still outstanding, and it would be absolutely fantastic if we could get some grant funding, put some research projects together that actually would look at this. But as soon as we can envision that project, we'll realize very quickly that North America has a multitude of different climates, many, many more than Europe altogether. And it would take probably about like 7 or 8 CPHIUS studies to do this accurately. So it's quite a bit of an undertaking. Then the third point here in terms of limitation, once we perform an analysis, we don't really get a comfort analysis back based on actual conditions and exchange with the interior space conditions. We get an approximation in PHPP. We get an overheating limit, but that is not very precise. It can't tell us any details when this is occurring, during what time of the year, and so on and so forth. We also have no ability to assess the mold or rot potential or condensation potential in a wall, and that essentially is quite a big deal for passive buildings because we're insulating now to very high levels, and that means we're retarding heat flow from the interior to the exterior. And as Joe Stubik put it so well in his recent newsletter, if you have a leaky building, it has a high drying capability, of course. Leakiness dries out. Now we're doubling up, we're restricting heat flow, and we're eliminating air leaks, and that makes our wall double more prone to condensation and to not enough drying potential. So we have a higher risk essentially for mold and rot, and we need to dial this in perfectly for the climate. The usability of the PHPP, so far, I just received again another inquiry. People have been asking since the very first class, where's the GPS to this tool? It's a little overwhelming. So in that sense, first thing we asked for from the Fraunhofer Institute when they put together this new tool was, can you give us a user-friendly interface that gives us a clear kind of like line of events where we have to enter things? And also what they then threw in there, which was very helpful and we didn't think of, was essentially also a little field that will tell us if we put something in that is incorrect or that is still missing. Very helpful. In my career of modeling projects in PHPP, I have spent multiple hours searching for the one cell that was responsible for not getting the right outputs in the end. So that is also very helpful. All right, so current building energy assessment, what are we using right now? There are a couple other issues. We tend to add a few other modeling tools to PHPP as well to cover all of our bases in terms of building science. And one of those is the DOM modeling tool that is available for free from the LBNL. For our thermal bridge conditions, psi value calculations, most consultants are currently using that modeling tool. And then to remedy the limitation of not being able to assess either comfort accurately or also to include maybe more complicated mechanical schedules into the calculation. At that point, a lot of consultants have resorted to adding even another third model to the whole modeling package, and that would be Energy Plus. They felt that the PHPP was not accurately predicting the overheating in specific rooms, and that is actually a good case to be made because North America has much higher solar radiation, and it's very tempting to use the south-facing glazing to meet the standard, but then that also easily leads to overheating. So that comfort check is actually really quite important. So these different tools are being used, as I already said. PHVP for very low energy use in load buildings, with also very low balance point temperatures. That's the hallmark of a passive house. We also use it to assess the interrelationship between the mechanical system and that high-performing envelope, and then also to design for these micro loads in those highly super-insulated buildings. So again, that works. We can use it to a certain extent, but we are still missing the hygrothermal interaction, so that points towards the lag time and also the hygrothermal performance of the envelopes. Now, for those hygrothermal performances of the envelope, there's yet another model that a lot of consultants are starting to use, and that is WUFI or Delphi. Various modeling tools are on the market to model the condensation potential within a wall given a certain R value and given a certain airtightness level. Why do we need this? I was hinting towards earlier already. We have less drying potential. We're reducing heat flow through the envelope. And if we don't accurately dial this in by climate, we might have a very quickly failing envelope. So it's really, really important to couple the heat and moisture transfer through these building components in relationship to the accurate boundary conditions, and that also means the accurate boundary conditions on the interior of the building. And that potentially can also change. So this is not always just one fixed set point. And this is what this is kind of mentioning here on the bottom. We still have no, within those tools that I just mentioned, we still have no actual boundary condition interaction. So what if there's always a certain peak time in terms of humidity in WUFI Passive within dynamic simulation, hourly simulation, you could actually dial in very specific schedules of interior behavior and moisture and temperature conditions. So, and then last but not least, and maybe the biggest plus for me that came out of this whole WUFI Passive exercise, the ideal world, that is the organization of workflow. So as you already could see in these previous slides, if you have a whole set of different modeling tools to assess energy performance and to dial in your design, and this is the key word here, we're still in the design phase. If we're still in the design phase and we're using all these different not connected modeling tools, there's a great potential for error. So we have to update all 4 of those, or 3, or however many we're using. So it is a really, really great advancement to now have essentially all these tools in one. You can now use the passive verification mode. You input all the geometry of the building, all the R values, all the components, descriptions, exactly, and that is the same set of dimensions that then is being used by the other components, by the dynamic model, as well as in the future, thermal bridge calculation model. That module is currently still under development, but that is envisioned to happen during this coming year. Also, a great new improvement is that we now can actually calculate the entire building from the perspective of performance. So that means we can now actually see the impact of the exchange between the opaque components and the interior temperature differentials and humidity, humidity storage, lag. That can now be calculated into the energy model. So for cooling-dominated climates, that might make a big difference in results. And that's the conclusion right here, better cooling assessment. Also, the capability to optimize and minimize mechanical system, this is very critical. As long as one has a very simple building and a simple mechanical system, that does not make that big of a difference. But as soon as we get into more complex buildings with different zones potentially, and this tool can actually also calculate different zones in one set, if we get into different zones at that point, we might actually have different schedules for mechanical systems with different mechanical systems altogether, so on and so forth. And then at that point, it gets very difficult with a simplified tool to really dial in the mechanical system for comfort in a particular climate, and especially in more challenging climates with high humidity and cooling nodes. So if we move on to the system climate factors for our design here, and this is just really quickly to give you an idea how complex that quickly can get. We have all these different factors in the United States, many different climate zones, 8 altogether. Alaska is not shown right here. If we overlay all these different heating degree days, cooling degree days, winter design temperature, summer design temperature, humidity, precipitation, solar radiation, night sky radiation, and ground temperature, if we kind of combine all those, and as you know from experience with modeling and PHPP, this all has an effect on the overall model, we get very complex patterns very quickly. So very quickly, just showing you here snapshots of the individual climate factors. Here, the annual mean total heating degree days, that still seems to be kind of manageable. If we go into the annual mean total cooling degree days, we already start seeing slightly different pattern develop. So while the heating degree days were kind of horizontal, now for cooling degree days, we see some kind of circular pattern develop. For summer mean max temperatures, we get almost like a vertical pattern developing across the country. And for January mean minimum temperatures, very clear horizontal patterns. So those go entirely opposite direction, like 90 degrees. Any mean relative humidity, vertical pattern. July mean relative humidity, vertical pattern. And mean relative humidity, and then the mean sunshine rate here, that is more like a radial pattern with two centers, like one up in the right-hand corner, in Canada, and one down in the southwest. July mean sunshine and mean sunshine. So all that said, what we hadn't created so far, and I'm glad to see now that the Global Building Performance Network out of Paris has actually done this research. They have a similar mission statement like us. They want to make passive building commonplace worldwide by 2020. So they have quite a challenge ahead of themselves. I think like country by country, this is already a challenge. But thanks to them, they tackled this worldwide comparison in terms of climates. And if you look at the slide right here in the upper left-hand corner, we have the heating degree days. Upper right-hand corner, cooling degree days. Lower left, we have the relative humidity. And then on the right, we have the average air temperature. So once we put all these together, we get a very interesting image. Not necessarily what we expected. And make no mistake here, the purple in Central Europe is actually different purple from like the mostly purple in the middle of the United States. But that's not even the biggest part. So really the closest is somewhere in between the Northwest and along this edge of this purple. But the most striking difference really is, of course, the green, cooling and dehumidification. Almost there is a proportion of subtropical area, and a very, very large area that is impacted by heating, cooling, as well as dehumidification. And it starts to look quite a bit like China. There is really no other country in the world that has that big of an area that is subject to these climate conditions. So very, very interesting once you start analyzing these climate factors. And if we now zoom back in to the core piece of Passive House, the minimized mechanical system, this slide might be a little bit come as a surprise after the big picture. This is now really the micro picture. What it is actually talking about is the essence of the Passive House. We are trying to design the envelope to the effect that our mechanical system now can be so tiny that it can provide heating, it can provide cooling, humidification, dehumidification, within a range of, like, let's say 2,000, 3,000 watts. Lower axis right here, we see to the left the allocation for heating, to the right the allocation for cooling, the humidification, and then latent humidification and dehumidification on the vertical axis. So this is central Illinois, and we can see very quickly that we have everything in central Illinois. We have all the necessities of a mechanical system of heating, cooling, dehumidification, and potentially even humidification. And that is the full range that we have to design for in North America. Now, there are a couple of climates that where it gets easier, where some of those things disappear. Like, for example, the high desert is perfect at that point. Actually, the heating almost drops. So it's very interesting how things change there. All right, that takes us to WUFI Passive. And so what we have now is a brand new tool that is built on the well-known engine of WUFI Pro. And you can see right here all the general data points that we have to enter into this balance-based assessment. And balance-based meaning is essentially the same energy modeling process as PHPP. It's the exact same thing. We're following the exact same calculations. These are all well-known formulas. So once you perform a calculation in this static simplification side of this new tool, then you should receive the exact same result as the passive house planning package. Now, in addition to that, once we do all this work already, we can, with a click in a drop-down menu, we can change from just the simplified passive house version over to the entire goodness of WUFI Plus, hygrothermal dynamic modeling. And you can see right here in the middle, there's also, this is essentially WUFI Plus. So now we can model the energy balance based on hourly data and see how, for example, thermal lag, thermal mass is impacting the cooling loads. We can model how the exchange between opaque components and the storage capacity for moisture can actually affect the humidity and the comfort and so on and so forth. And then in addition to that, we have our WUFI Pro hygrothermal envelope simulation. That's probably the one that most of you are familiar with. That would be the function that is currently available for free in the WUFI 1D version from ORNL. So essentially, those three functions give us the whole building simulation options. If we feel confident we're in a simplified climate, mostly heating dominated, and we don't have any of these issues with cooling or humidity or comfort or too high solar radiation, we are fine to stay in the simplified passive version. But if we feel like, okay, we really need to check on this, we either have like maybe a hygrothermal issue with the walls, we're not sure if our vapor retarder is in the right place in the wall in that particular climate, or we're not sure that the cooling is accurate enough and we want to see what the thermal mass does, then we switch to these dynamic modes. And this is how simple that switching. It's just a drop-down menu right up on top of the menu for WUFI Passive. And you can toggle back and forth as you like. The same data points that you enter in the passive house verification are used for the other modes. So there's no double entry, no potential for mistake in terms of repetitive entry. Quickly here, most of you are probably familiar with the movie hygrothermal performance simulation from WUFI 1D. And in addition to that, now in WUFI Passive, once we switch to the dynamic mode, we also get the entire building load calculation. And of course, same stuff goes in there: weather data, exchange rates, inner loads, set points, AC. All nothing new. So essentially, this is the new interface And you can see right here, this is set to passive house verification. So that is actually the WUFI Passive side of things. And this is showing you right here the tree structure. This is what I was starting to talk about earlier, the GPS now, that kind of like organizational tool that allows us to go from component to component and also from zone to zone. You can see right here there's like one zone, it's a little tiny, but I hope you can see this. It's my arrow right here. You can add as many zones to your project as you like. So if you're working on a multi-family project, for example, you have 4 stories, apartment, passive house building above, let's say, a commercial store. At that point, you can create a second zone to separately calculate the store, the commercial space by itself. Also, you can copy these cases. So this is something that got me really excited. I found myself getting so excited in PHP many times, being able to switch everything around and seeing the different results of the different changes. And then I did it so many times that I couldn't remember what exactly I did. And then I tried to come up with very time-consuming kind of logs to keep track of my changes. And that's all possible with Excel. That's perfect. You can actually build those things. But in this one right here, you can actually just copy a new case down, call it case 2, and then you keep track of all your cases. And it will manage those within one file. So that's a really nice new addition to this thing. You can see in the left-hand side on the bottom right here, we have 3D interface. We have our entry field up here. This is where the data goes in. So if you don't want to mess with the 3D interface at all, you can do that. Just put your data in and never bother about drawing anything. And then on the bottom right here, this is our output field here. In this particular specific case, this is in metric. We have a common passive house criteria, space heating demand, heating load, pressurization test result, and so forth. And then there's this little green light, little green button right here. Now in this case, everything has already been filled out correctly. But if for some reason you made a mistake or you're missing a data point entry, this one would turn red and it would tell you the path to where you need to fix the entry. So that's very helpful. Okay. And that's already what I just talked about. Yes, so these are the main parts. Okay. So as we're moving on to the building input for the components, that's actually really cool. And this is a brand new module that Fraunhofer software developers have created specifically for the passive house community. They did not have the capability in WUFI Plus or Pro to calculate inhomogeneous wall assemblies in terms of R values. So they developed this whole new model for the passive house community so that we can get our stud walls in there and that we can correctly calculate the reduction of structure inside of our wall modules, just like it happens in PHP. So that's very cool. And as you can see right here, there's a 3D interface. You can actually draw this in 3D. You can even click on your module and you can spin it around. So it's very nice. In addition to that, there are a whole bunch of databases already stored in the tool. Fraunhofer is very serious about supporting this tool and to continue to develop this tool. They have launched it worldwide. This is not just a US or European thing. They are, for example, in Korea right now, looking at that market as well, and Japan. So once you get the software, you'll find there are actually databases in there for various Asian regions and Japan and so on and so forth. So quite interesting. They are really seeing this as the way of the future. So that ties us back to kind of like to the global performance building network. They are really indeed, the international community is envisioning this level of energy efficiency for worldwide market, which is good news. This is excellent news. So now here on the bottom side, you can actually see the BTU version. Oh yeah, I haven't mentioned that yet. Up here, there's a little button, and you can toggle back and forth between English and IP units as much as you like, every 5 minutes if you want, and it will update and convert automatically. So very user-friendly. You don't have to think about conversion. You don't have to think about keeping track of anything. You can work in either, whichever one you prefer. As I said, then it will appear as kBTUs per square foot and year the way in the IP version so far as well. So if you are as courageous as Adam Cohen is, and your first passive house is not a box, but a more complex building like his seat building right here, the first educational facility in Virginia. At that point, you might want to use a handy-dandy new feature, this Google SketchUp model. So more complex projects or simplified projects, you can import through a SketchUp interface. And it doesn't have to be a very complex SketchUp model. It can be very simple. Windows can be just squares. They don't even have to be inset. It's just a certain protocol how you have to identify various areas and then import it into WUFI Passive. There were a lot of questions in regards to other modeling tools, and the answer yes, it's yes, but it's of course way more complicated to try to hook this up to BIM or AutoCAD. Fraunhofer is actually looking at that as well. But as a first step, here's our Google SketchUp import, and you can always export from AutoCAD to Google, and then from there to WUFI Passive in the meantime. All right, so the passive house input components, and this is what I was kind of alluding to earlier here. This is actually your little image where you can kind of take it and grab it and spin it around. And this is where you start building your inhomogeneous components, brand new, hasn't been there before. And again, you can build your own wall assemblies. There's a materials database. There are already a few materials in there, but you can then save your own. And once you have like the material database built that you always use, this should go really fast. You can very quickly choose from that database, and it pulls it up automatically. We are also planning on building databases for product manufacturers and enter them into the databases directly. So for those folks who buy certain products, they can then choose from that as well. But that's still in progress. We are not there yet. And that the same would be true for mechanical systems. Passive house inputs, you'll find that these are exactly the same ones, again, as you know it from PHPP. We have the average thermal conductivity of the glazing right here. We have the solar energy transmittance, i.e. solar heat gain coefficient, and then left, right, top, and bottom psi values right here. That's all familiar data that is being required in this tool. Just as well. Passive house outputs. Now, this is another really cool thing. Fraunhofer has been watching very closely the PHPP dashboards and contests, and they scratched their heads and they said, like, everybody's building these dashboards for themselves and to communicate to clients, and we're just going to build this right into the software. And by the click of a button, you get like a 10-page output with the nicest like pie charts and graphs and everything you ever wanted to know about the data of your project. So that is really, really nice as well. You can just have it outputted in a second. And this is just like an example right here how this would look like. It gets way more detailed, as you can see right here, detailed information on all of the fluxes, graphical representations of all the values, and of course the relevant values for certification. So PHIUS is now also accepting WUFI Passive for certification. Quickly as a summary for the passive verification mode in WUFI Passive, we have instant calculation and case comparison. That's going back to that tree structure right there where I told you you can store a whole bunch of essentially infinite cases, as many as you like. We have automatic area calculation. So if you bring in your project from SketchUp, or if you draw it in this little drawing wizard, you can also draw inside of this software. It's a little rudimentary, but it works. So at that point, it automatically calculates all the areas. You don't have to calculate anything. It just outputs it. 3D visualization. I found myself being very happy about that. I wasn't so sure if I really needed it, but once I had it, I'm like, yeah, I am an architect. So that was a bonus for me. Google SketchUp import for more complex units. We have SIIP units back and forth. User support through PHIUS and Fraunhofer input in decimal feet and inches. Additional calculators, like for example for TFA, pop-up that you can choose when you get to those particular areas, and the databases which will keep growing specific to the North American market. And at that point, this takes us to the dynamic simulation. Now, the dynamic simulation is as easy as I said. You go back up to that drop-down menu and you toggle to WUFI Plus. And there's a little bit of a catch to this before I move on. So essentially, it's a good catch. Essentially, Fraunhofer gave us a really, really good deal when they approached us and they said, we need X amount of dollars for this tool. We said, there's absolutely no way. Our community will not be able to pay this much money. And they said, like, well, okay, we're going to cut you a deal. Because essentially what they're doing here is they're giving us the full WUFI Plus modeling tool, which as a standalone is a very expensive professional tool. I think they're charging roughly like $6,000 for that. And that is for a lifetime license, which in their terms is 10 years. So you get all the upgrades and updates that are happening over the next 10 years. For the Passive House community, they're giving this to us for 2,100 euros. And that is quite amazing. Now, where's the catch, right? How do we get like basically the whole thing for half price? Well, they are saying, well, if you truly work in Passive House design, then you got to be within 10% of the Passive House certification criteria before that dynamic simulation unlocks. Now, that's an okay idea. We still have to go back to the negotiation table on that one, because when we agreed on this, of course, we weren't really thinking ahead and we were not thinking about retrofit. So we will have to find some way to qualify retrofit projects to unlock at a higher level. Anyway, that's in the future. But the great news is Fraunhofer is super responsive. Any kind of input, we've had excellent feedback and immediate results of being things implemented in the software. So now, what do we do on the dynamic side of things? I already mentioned schedules for HVAC equipment. So as of right now, it's very difficult. As soon as you move from like a very simple small building to a more kind of like complex building where there are schedules like you turn the ventilation system off overnight, or you even have like on a weekly basis different schedules, like on weekends everything is off and then it only kicks on during the weekday. We can't really predict comfort with a simplified tool. In this one, you can enter as many specific schedules and set points, ventilation rates, interior loads as you want. You can specify that absolutely exactly accurately, comparable to NRG Plus. So this tool is able to handle quite a bit of complexity. Components. So in regards to components, now what we're interested in here is the thermal storage of the materials that are close to our interior space and the hygrothermal properties. So we want to know, can these materials actually store some of that humidity and buffer some of that humidity? That's going to be very interesting in the humid climates. And then, of course, also if we have any sources in the assembly. So I don't know how many of you have ever really used that little faucet option that you have in WUFI, where you can actually create a leak in your wall assembly. This might actually be not a bad idea for Passive House assembly to play that through, because we have so little drying potential. We have an airtight wall. If we really want to check a worst case scenario, we might want to check on sources in the assembly, and that means also a potential leak. Okay, so this is the final output right here on the dynamic side of things. And that's where it gets really kind of cool. You're going to be able to see, based on each component that you entered in that little tree, exactly how much you're gaining and how much you're losing through each of those. And you're also going to see, in regards to the HVAC equipment, for example, right here for the Dublin house, this was a big aha moment for us. In PHVP, we could only guess what the right windows might be, and we were pushing the windows really hard to make it to the 15. That turned out to be a real mistake, because if we zoom in right here in this dynamic model, we find that during very specific times, for a couple weeks here, actually we have days where we have heating and cooling at the same time, and that even with the shading entered. So those dynamic outputs on a daily basis, we can see right here the HVAC system is actually working. This one right here is heating. Heating? No. Okay. So this one is cooling, and this one is actually heating. And that's, of course, something we don't want. We want to optimize for that. We don't want to create the situation. And this tool now actually allows us to dial in windows much more accurately than the PHPP did. There we only were able to guess. Then also in terms of comfort, these are a couple other outputs right here. And in this regard right here, in terms of going too fast. Let's see if we can go back. Here the ASHRAE 55 comfort assessment. You can see that in this range right here, we're clearly outside of the comfort range. So now we can go back in and we can change our design, we can tweak our equipment, we can tweak our envelope, we can tweak our windows, and we can get this back into where we have a satisfactory comfort range. This is also quite interesting. Dynamic output of all the heat flows and fluxes for the Dublin house right here. What I thought was particularly interesting was, if you look at this, the red is the solar heat flux. That is almost the same in summer as it is in winter. So while the shading catches in the summer, there's still plenty of reflection and conductivity, that there's still plenty of heat flux through these windows in the summer. And also interesting how much heat we're taking on in the summer through the opaque partitions. So this is all very interesting stuff to go back to your envelope and to really dial it in for your particular climate. This is just pretty standard output here. Humidity distribution in your wall assembly. Most of you are familiar with that. Hygrothermal component performance. In this particular case, this line right here would be the OSB on the exterior, on the interior of the wall. This is the one, this is our vapor control layer. We're concerned with that one, and that looks fine. And then, again, this is the movie output. If you wanted to show this to your client, WUFI Passive has actually an export function for the movie itself. All right, export functions. There are a whole bunch of export functions for all the data that is in there. I don't want to dwell on this too long. We're kind of running a little over. Quickly, summary of the WUFI dynamic mode right here, what we can do with that. We have the dynamic hygrothermal whole building simulation. Now that will impact our final energy criteria. So whatever it says in passive house verification might now be updated by additional impacts of thermal mass and potentially humidity storage. Then we have an easier to use graphical interface right here. Well, that's the same thing. Multi-zone model, that's a big deal, that we can now actually assess comfort in multiple zones. These things are the same as a WUFI Passive 3D visualization, Google SketchUp, IP, and SI. Extensive databases for materials and comfort analysis and hygrothermal component analysis. That just quickly as a summary. And I think I have just a couple more. Examples for additional modeling options. Now, I'm not so sure if this is already implemented, but that's what Fraunhofer is working on as well. Many of you have run into the snag when you go for certification that you underestimated the shading, and we are now asking for actual on-site verification for the shading percentage. This tool will soon be able to give you a pretty accurate number of the shading of your surrounding. Not in there yet, but that's the plan. Various ventilation strategies are already in there. Thermal and hygrothermal inertia are already in there. Different utilization patterns. Yes, you can absolutely and totally specify it to the T if you have a commercial building. Insulated shutters, you can model this right now. And all that in dynamic mode leads to better envelope optimization. Overall plan improvement. So I mentioned this previously, thermal bridge, yes. So now imagine this tool and add thermal bridge calculation to it. Don't even have to deal with therm anymore. Fantastic. The first module is already built. You can kind of like walk around in it. I think there might be a slide actually. Oh no, there's not. But that's also really, really quite cool. In fact, more accurate than therm because they're building it in 3D hourly simulations. So now even for the therm calculation, we can take into account convection in the corners where we're trying to calculate a thermal bridge at, for example, a slab connection to a wall. Absolutely, totally cool. Also important for windows, for example, because windows might not perform the same in hot climates as in cold climates. And what does the convection in front of the window do to the thermal performance and so forth? That all can be kind of assessed through this new model as well. Passive house verification, all the same stuff that we were able before, plus a couple of new features. We have the output certification documentation, which is really awesome, and standard adaptation is in the offing. Fraunhofer has voted to do their best to research and to move that forward as well. And dynamic simulation, now we can model our HVAC more precisely, but of course we're not stopping here. We're also looking to make it better for that. We're looking for net zero and plus energy plugins that allow us to design the perfect system that now takes us to either site zero or plus energy. Oh yeah, and I was mentioning this up high with the therm model, the enhanced dynamic window model. That's something really, really exciting from a building science point of view. So I can't wait to see that develop. Summary, why WUFI Passive? Well, most important argument for me is like one tool that is a risk assessment tool for the designer, for the architecture office. You eliminate potential for mistakes. You have it all in one file. If somebody comes to you and says like this building failed terribly, you pull out that one file. You say like I ran the WUFI, I ran the therm. Here are all the calculations, and it wasn't me, essentially. We have a user-friendly interface, the workflow itself. You can manage your iterations easier. Also a big plus if you are the boss. If you're not the person who is actually running the actual model and you're head of a larger firm, you will not be able to really go into detail and know about every decision that is being made. But having this all-comprehensive tool, you actually can go in and at least spot check to make sure that everything is correct. We have an easy toggle between verification, static and dynamic simulation based on what level and granularity of outputs we would like. And again, one building model for all features eliminates mistakes. Pre-enter databases, you build your own. And the result export functions, again, I wish I had like a shot of the pie charts right here. Pretty impressive. They are in there as well. So, in conclusion, the all-in-one is the best selling point. Now we have energy, comfort, and hygrothermal performance all in one. And also very comforting that we have a responsive software developer that will help to constantly improve and implement new features, and hopefully also do that in response to what our market needs. And I think that takes me to the end. If this got you interested in WUFI Passive, we have these 2 WUFI Passive trainings come up. There are also CPHC trainings coming up in April. So check out our website for those as well if you're not a CPHC yet. And we hope to see you there. Thank you. Hello, Mark.
Hello, Katrin. Do you feel like you have a few minutes to take some questions?
Sure.
Okay. If you look at your control panel, there's a whole there's a whole bunch in there. Feel free to answer the ones that you care to. We may have a few. Do we have any questions in the room here in Chicago for Katrin?
One of the things that I'm not clear on is you still have to enter your data in PHP as well, right? No, it's just one program, PHP is gone now?
Okay. Can you see the questions there, Katrin? Or I'll read them to you if you'd like.
Yeah, please.
Okay. The first question I have here is, when will the geometry input accept Revit models?
Well, that's for Fraunhofer. I know they are working on it, but that is a very complex issue to connect the 2 tools. So I don't know. I know they're feverishly working on it, but I don't have a timeline.
Oh, I can't. Another question, looks like the software is no longer Excel-based, obviously. Will all the formulas that the calculations are based on still be visible?
No, this is actually now the black box phenomenon. And I wasn't sure how I was feeling about that at first either. So if you prefer to build your own spreadsheets and to see the formulas, the Excel spreadsheet might be the tool for you. For those of us who might not necessarily need to see those formulas, and I know them now in and out from PHP, I'm fine. I just want a very fast, organized workflow. That's totally preference, yeah. But it's the exact same formula. So if you wonder what is behind it, you go back to the PHP.
Okay. Another question, they're curious if the software will run on a Mac.
Yes, it works with a little bit of a trick. There's one thing that you have to adjust on the Mac, but that's really only one. If you don't, you get like antennas sticking out of your model, which is still not impairing the model, but it looks funny. But there's a fix for it.
Okay. Next question is the calculation engine used the Energy Plus and or TRN-SYS, which I'm not familiar with? If not, what calculation engine is used and how was it validated?
What's the question if Energy Plus is used? I'm sorry.
Yeah, it says, is the calculation engine used using Energy Plus and or TRN-SYS?
No, it's the WUFI Plus engine, WUFI Pro, I believe. Yeah.
Okay. Any discussion groups such as the WUFI user group or on LinkedIn for folks who are using the program already?
Yeah, actually, the Fraunhofers have a WUFI Passive wiki, and then there's also the WUFI forum for questions. And we just started one as well after the first WUFI Passive training in New York City. But we have to restructure that. We have to find a place where we can make it more public, like on our bulletin board, Mark. We were discussing this, right? So that people actually can benefit from the questions that are being asked.
Absolutely. Another question is, what will we learn in the 3-day WUFI Passive training that we can't get otherwise?
Well, if you like to try to teach it yourself, that's fine too. After having gone through it, I would go through it again, and in fact, yeah, it is. I think it's very helpful because it might take you some time to figure out all the SketchUp imports and the intricacies. It's a shortcut.
Can you please explain again the unlocking of different portions of the WUFI program?
Yeah, so WUFI Plus is the actual engine, right? The deal that Fraunhofer made us essentially was if you get within 10% of the 4.75 kBTUs per square foot in here for heating, then the dynamic side unlocks. So before you get into the range of passive house certification, you can't really see what's happening in the dynamic side. Now, we are renegotiating that one. It seems that margin is a little tight, as I said, for sure with the retrofit applications.
Okay. Does WUFI Passive calculate heating and cooling loads dynamically, or would they be a required input?
No, it calculates them dynamically, and that's an excellent question, and I forgot to mention that there are actually two different climate data sets. The passive verification accepts the PHPP climate data sets. So the ones that we just made free on our website, 1,000+ sets, not too long ago, you can still use those, download those, and you can import them in the SI version. You can't import them in the IP version, but you have to set WUFI Passive to the SI version, then you can import the PHPP climate data sets. For the dynamic model, you will have to work with a climate data set that is as close as possible to your actual location, but you can also request a custom data set from us, but there are just not as many there yet. We're working on it, but we have limited capabilities. So we're looking to make those 1,000 sets available as well as soon as we get to them.
Okay, just two more if you have time. It says here, the tool is getting pretty deep into the typical engineering realm. Is it appropriate for builders and architects, typically CPHCs, to use?
Yeah, I think so. Just from the perspective of organizing your workflow, you never really have to touch the dynamic side of things if you don't want to. You can stay entirely in the static side of things, which is simple and fast. And if you're in a climate where you're not concerned about hygrothermal performance of your envelope, heating, cooling, any of those things. So I'd say the dynamic side is probably the greatest learning curve. CPHCs who have already worked with PHPP, they'll find the passive side of things pretty easy and essentially the same.
Okay, last quick question is, someone's curious if the WUFI training sessions will be recorded and possibly posted for online viewing.
No, not at the moment. Yeah, I guess I leave it at that.
Okay. Well, two quick announcements I wanted to make is this webinar presentation has been recorded, and in about a week we'll post it in the members only area of the FAIUS website. Or if you came in late, if you contact me, I'll make sure that you get to see it. Also, if you're a CPHC, you will get a continuing education learning credit from attending tonight's webinar. We will take care of the registration of that for you and forward all the attendees down to the FAIUS office. So with that being said, I want to thank you, Katrin, for another wonderful presentation and for your time this evening. If anyone is interested in the trainings or more information, our future webinars and other